then you put a 2 out front. What does the 2 out front do? Ooh, I got you 2. Right? And then what is if it was like 2 parentheses x plus 2? Just move it right here. Right? And then it has the minus 3. You get what I'm saying? You guys remember how you can move it? I don't do it very well, but you get the idea. You can move things by doing translation, rotation, and all that fun stuff, right? Okay, what I'm going to do today is give you the hardest one we can do. Okay? The beast of all beasts. You can do the beast of all beasts, you can do any one of them. Because everything else has these type of things within it. Does that make sense? You just don't have to do it. Okay? What kind of carousel do you guys want to play around with? You guys want x cubed? X cubed? What is x cubed? Oh, that ain't the hardest one. Wait, hold on. Okay. I'm not having, I will never do it. That's just lazy. Okay. The vertex? Does this really have a vertex?
Cross that.
Woo!
Cross
You
that.
could say it has a humpy hump thing.
Sure. Cross that.
That's the humpy hump? Is that not the correct terminology here in class? Sorry. Okay. I don't know what to call it. It's like in the cubic. A humpy thing. I got it. You mean a turning point? There you go. That's more mathematically correct. Yes, that is. A turning point. But that's technically not a turning point. It's still increasing the whole way. Touche, brother man. Woo! Take that. It's not a turning point. But you get the idea where it kind of flattens out and starts steeping back up, right? That's what the humpy hump is. Okay. All right, so what I'm going to do is I always draw my parent function. That's y equals x. Now, how many of you guys feel you're more visual people? Awesome, you got the wrong teacher. Because I hate visual. It's not me. I will try my best, but I'm not a visual person. So therefore, for me, when teaching, that's not my style. I will try to do my best. I'll draw the picture the best it is, but when I do it, I think chart. I think numbers. Okay? That's me. So, if that isn't you, then you might want to watch it on the video. Or I'm going to show you the best I can. And I will. I can still do it, but you still have to get the idea of what you're doing. But still, it's the same way you might just do it with a picture instead of the numbers. Does that make sense what I'm going at there? Okay. At least I'm honest. I'm telling you I'm not a visual person. Okay? You saw my picture from all there. That's a good thing. Okay? All right, here we go. What's a nice numbers picture of x cubed? Okay? I have -2, -1, 0, 1. You know some nice values, right? So when I plug them in, I get -8, -1, -2. So if I graph that, basically because that looks like, correct? Oh, 8, it's an 8. Thank goodness.
no, maybe so. That makes sense. Hannah, you good? That's right. Okay. So ladies and gentlemen, what this graph looks like is x. So if that was that tight, this one's a little wider. Because it takes wider x values to get the same y values. It takes bigger x values to get the same y's. Because we just cut all our x values in half, right? So remember, why do we move to the left 3 if we had that? Because that's the value that makes it 0. 3 would make that 0, right? Does that make sense what I'm saying? So notice, why do we move this to the right 6? Because everything, how do I get back to 0? If you get 6 minus 6 gets you back to 0, doesn't it? Remember how you guys, maybe somebody told you it's just opposite of what you see? So we see timesing by a half. What's opposite of timesing by a half? Dividing by a half, which is the same thing as timesing by 2. So anything on the inside your function, just think about it as doing opposite of what you see. So I see timesing by a half, so I'm going to multiply by my x values by 2. I see this minus 6. Give me 1 second. I see this minus 6. So what am I going to do? Instead of minusing 6, what do I do to all these values? I'm going to add 6 to the x or the y. Am I inside or outside my function? Inside. Because I'm in the inside, I'm going to go ahead and not multiply, but add 6 to my x value. And I'll prove it to you that it still works, okay? So here we go. So this would be 2. You got to think 4, 6, 8, and 10. And notice this would still give me these values. The key thing I'm trying to do here is save these values. What x values would still get me back to these values, so that you can actually see what's happening to the graph, right? You want the graph to stay the same. It's called a dilation. Not a dilation, a transformation. I don't want the graph to look differently. I just want to move it places, right? Does that make sense? This guy was a dilation. Okay, because I went from here to something a little bit bigger. I dilated it. It's not the exact same picture, right? Does that make sense what I'm saying? Now I'm here. Now I moved him. That's called a transformation. I'm just moving the exact same picture, right? Okay, so I want it to look the same, so I want the y values to be the same. Makes sense what I'm going for there? Okay, notice, plug it in. And when in doubt, try it out. I made that out. 10 minus 6, 4. 4 times a half, 2 cubed. So the same thing. I'm doing the transformation, but I'm doing it with numbers. Okay, notice this graph, all it did was move this graph 1, 2, 3, 4, 5, 6, a little bit wider. Still the same thing, right? Still fat, still good to go. Everybody with me on that? Now, am I have any more inside things? Have I done everything on the inside? So are these x values going to change the rest of the time I'm working with it? No, they're done. Now I'm going to adjust my y value. So that last chart was once again y equals, is it negative a half or a half? There's a half right here, right? I'll get the negative 2 in a second. So it was a half x minus 6 cubed, right? And what was that chart again? 2, 4, 6, 8, 10, and then negative 8, negative 1, 0, 1, right? So that was our previous, just because it's gone, so I wanted you to see it. So now we're going to here. Ooh, somebody said something. I just want to help. So, did I ever answer your question? I didn't. What can I help you with? We will be. But right now, I'm just, part of the main idea of this is transforming it today. Of today's lesson. No, you're okay. I probably didn't hear it well. It's transforming or transformations of graphs. So moving it, taking a parent function and adjusting it to do what it tells us to do. Does that make sense? Like stretching it vertically too. No, that's okay. I never probably said that. Is everybody with me? We will be solving for zeros too. Because if we're in this fashion, it helps us find zeros pretty easy. We can solve for them. We don't have to do quadratic or things, but it doesn't give us all the zeros. That's why they're numbered like this. Okay, yes. Say what? what I did, just to let you know, Kelly, I just moved all the x values to the right 6. Or you're wondering how I got the 6. Or you're wondering where I got this from? Okay, so you're wondering from here to here. Okay, so remember transformation. Do you remember just x squared, what it looks like? It looks like this, right? What was x minus 2 squared look like? Do you remember? Over 2. 1, 2. Same graph, just over 2. So I took this graph, moved him over 6. That's all I did. Is that okay with you? All right. Oh, no. Okay, so once again, I'm outside. This is now outside my function. Okay, so I'm done with my x's here. I played with the x's. They're good to go. Okay? Anything outside your function, where does that involve? The y value. Does that make sense? Uh-huh. And on the outside, you do exactly what it tells you to do. I'm going to take my y values and I'm going to times it by what? Was it a negative 2 or a 2? It was a negative 2. Okay, so therefore, instead of being negative 8, where am I going to be at? I'm going to be at 16. Instead of being at negative 1, I'm going to be at 2. Instead of being at 0, guess where I'm going to be at? 0. Instead of being at 1, I'm going to be at negative 2. 8, I'm going to be at negative 16. Because what that did is basically, here's my graph. This is what we had, right? So now, instead of being here, it's stretched, right, because of the 2. Does that make sense? We're still fat, but then it goes, you get what I'm doing. I'm trying the best I can here. Okay, but then the negative, whoom, flips in like this, right? Everybody kind of get the idea? That's my visualness for you, the best I'm getting. Okay, I'm doing my dances. I'm a great math dancer, I tell you that. Okay, so once again, this graph looks like this. 1, 2, 3, 4, 5, 6. So a little bit fatter, right? Now this graph looks like this. It's probably fatter, and it was stretched higher. Does that make sense? That's what happened. If you plotted those points, that's where there'd be the difference. Because notice, it was at 8. Now we're at 16. So we are stretched, like, it was like this. So what's your plan, Stan? You made a commitment to driver's ed just as much as your dad's do. That's all I'm saying. So I'm not trying to pick for you. Just think about that. Nobody ever wants to pick the education as their important part. But, alright, so realize it. Okay, find a good corner. Okay, so I'm going to still keep these guys. Alright. So now I take this. This is what was what the heck? It was minus what? Now, is this taking a lot of work? Yeah, are you going to have all of these like this one? This is, like I said, the most you can have, right? It's a 4-step guide. Oh, sorry. Is it 4 or 6? Let's see what we did. We did our parent, right? This would be step 5. That's what most of you can have is 5. Parent, horizontal stretch, horizontal shift, vertical stretch, vertical shift. Yeah. Okay, let's listen, guys. Go ahead. No, I'm trying. My ears are so full, like pressure on them. So I'm trying to listen to you better. You're good. I'll help you out. Okay, I'll keep going if you find it. Let me know. Okay, so now I take these values. What am I going to do here? Drop them down 4, right? Yes, ma'am. Just in general, to graph it, but using transformations and not just random points. I'm doing every transformation there is that I can do step by step. So some people, like, once again, what if I don't know if I've said it in this class, but I say it in my classes a lot. A graph is a collection of points so close together that they touch, right? So could I get to this same graph by just plotting a bunch of points? Yeah, I could graph a bunch of points and I hopefully will get my graph, right? Does that make sense? But if we know the idea of transformations, we can just kind of, I can sketch something really easily if I was looking for a sketch. But I'm trying to get it to it pretty fast. Yeah, parentheses. Okay, so therefore, notice I'm dropping him down 4. Basically, to answer your question, Miss MP, and I'm sorry if I didn't do this better, is I'm trying to show you each transformation or what each transformation would do, but I'm doing it all to the same one, because you can do multiple transformations and dilations, all these things to one thing, right? Okay. So now that one takes this graph, and we go 1, 2, 3, 4, 5, 6, down 1, 2, 3, 4, and it's the same graph, it just shifted down, right? Basically what I'm trying to say is that's my end picture. Now that's the sketch, that's not the exact point. Yeah, put a 0. Not trying to bother. And there's my graph. Could I do that? Sure. Like if I looked at this thing, I'll tell you exactly what I see. Okay, I see, oh, I have to make this fatter. I have to move it over 6. I got to go down 4. And then that -2, instead of looking like this, it makes me flip. And now because it's 2, I got to make it tighter. I mean, I can graph that. But is it a perfect sketch? No, that's a sketch. Okay, why did I get wider? Okay, I got wider. Let me explain why the wide. Now, I'm not doing the perfectest thing with my body. Okay, so here's my parent. The half makes me wider. Still the same y values, but it takes bigger x values, so I'm broadening out, right? Does that make sense? Okay, so now I move over my 6. So I got the same graph, I'm over 6. Okay, now the -2, negative, same broadness, just flips me this way. Now the 2 steepens me like this. And I'm still broad, but I'm steep like that. Does that make sense? You with me now? Because of the 2. And then now what do I need to do? Down 4. That's a good visual. Come on now, that was visual. Okay, thank you. Okay, but that's basically what we're doing. If you understand the ideas of what everything does to it, that's the key idea, but I'm looking to be more exact than just a sketch. Okay, yes sir.
So in this instance, would it just end up being kind of the same because make it more broad by half?
I stretch it by 2, almost, yeah. Really is. Okay, so we only have 5 minutes left. But that's really a lot of it. Now what would I do if it looks like this? The exact same problem, just looks like this. No. Oh yeah. G of x equals, was it -2? Sorry, hold on. And they show you this graph right here. That's a graph that nobody would come up with the original equation, right? But does it have x's and y? Could I make a chart about it? Could I do the exact same things I just did there? So it's the same idea. It doesn't matter what the graph is. We do the same exact steps no matter what. It's just the parent function's different, right? And what this means right here is that you're doing it up a function. Hey!
What are you drawing there?
A funky picture. Looks like a reindeer. I don't know. Back in the day, I used to make this hangery thing in kindergarten. Yes. That just means a function. Like, see how this is inside my function? We don't know what function it is. We just call it the function. So in our previous one, it was the x cubed.
Oh, that's fine.
Yeah. Okay, let me finish up. Yes, ma'am. Go ahead. Inside out. So the ways that I did it, parent, stretch or vertical. I mean the horizontal shrink or compress. Okay, the number in front of the x, right, on the inside. Then your movement. Then your vertical stretching or shrinking. right? And then you're up and down. So the step that we went in, that's the order you're in. Okay, two more things, guys. So if I ask you to write this equation right here, let me look at it. I want a good one. Vanessa, will you come in or something? You guys have the best. Okay, so I have these points right here. It's at 0, 5, negative 1, 4, negative 3, negative 4. And it has this graph, and it says it is a cubic. And it asks you to write the equation. Okay? So we're going to write the equation just because we can see the shifts. Does that make sense to everyone? Yeah. Okay, you guys, how do we get from, notice this guy originally starts with 0, 0 for our little Humpty Hump point. I'm sorry, that's the best word I can come up with. If you have a better one, let me know. But you get what I'm saying. Close on turning point, but not there. Okay, so that point went from here to there. How did we do that? We went up 4, left 1. So doesn't that look like x plus 1 cubed plus 4? We know that for sure, don't we? Because we went over 1, up 4, correct? Now, we don't know if it's been compressed, stretched, or stayed the same, right? So therefore, there's an a value here. Notice that's why they give you other points. So this point 0, 5. So what do you guys think I'm going to do to find that a value? Plug in 0, 4, and 5 in for y, right? So I go 5 equals a, 0 plus 1 cubed plus 4. What's 0 plus 1? 1 cubed. 1 times 0. 0 plus 4. Oh, excuse me, that's 0. That's a 1. What the heck was I thinking? That's an a. Equals 5. Let me do it one more time just to math. 0 plus 1 is 1. 1 cubed is 1. 1 times a is a. Subtract the 4 over a is 1. There's my equation. Because a is 1, I just go back to the original and switch out a with the 1. Would it have worked the same way if I picked the other number? It would have. Watch. I'll do it. I'll just make sure. Negative 3. Negative 3 plus 1. Negative 2. Negative 2 cubed. Negative 8, right? A plus 4 equals what? What number is here? Negative 4, so I subtract the 4. Negative 8 equals negative 8a. It doesn't matter what point I get, I still get a to be what? 1. And I can write an equation. You are doing the odds. Okay? And then the other part that we have is actually ask you to find the zeros. So like on number 4, we'll do number 4 together really quick. 0, because there's a y there, but as soon as it said 0, I plug 0 in for y. That's plus 5. Cube squared, what is it? Cube? I think we're all. Yeah. So I subtract the 5, the 10. Okay, so now I'm at negative 10 equals 2, x plus 5 cubed. Divide by 2. How do we get rid of cubes? Cube root. Do I need to do a plus or minus when I'm doing a cube root? How about a fourth root? Yes. Any even root you got to do plus or minus on, okay? So I do that, and then notice that's the cube root of negative 5. Does that make it imaginary? Nope. I can have negative odd roots, right? Because what's negative 1 times negative 1 times negative 1? It's negative 1. So the cube root of negative 1 is negative 1, right? We can have negatives. Does that make sense? Okay, and then last thing, just subtract the 5. So negative 5 plus cube root of negative 5 equals x. That is one of the zeros. It's only one of the zeros, but I'm not going to make you go find the other ones. You could. Does it ask you to find all zeros or just a zero?
Find all real zeros.
All real. That's the only real. Good for you, because the other one's going to be, you would have to do synthetic. Go back and do synthetic with that being your 0. No, I'm not making you do that. Yes, ma'am. Because So when you solve, that's the only way you're gonna get is real zeros is by solving in that fashion. The other ones came out by the other. Okay? Gents, whatever you did, thank you so much. I will. I can do it. Or you can take it Mr. Jones. That's where it goes, Mr. Jones. Hey guys, you're amazing.